Welcome back everyone. In this video we will study about root finding of system of equations. So suppose there are I equations and each equation has j variables. I mean there are j unknowns in each equation. So suppose we have fi which is having j parameters and we want to find out the solution of this system of equations. So for example, let's say if I is equal to 2 and j is equal to 2, then we will have f1 x comma y is equal to 0, f2 x comma y is equal to 0. So this is what we are talking about. These are two equations and we need to find out the solution x and y for which f1 is equal to 0 and f2 is equal to 0. Now for this we will use the the Taylor series first order approximation. So what does first order approximation says? That we have f of x comma y is equal to f of x naught y naught plus x minus x naught f x x naught y naught plus y minus y naught fy x naught comma y naught. So since here we are talking about system of equations, so the first order approximation which we wrote was f of x new y new is equal to f of x old y old plus x new minus x old differential of f with respect to x at x old y old plus x y new minus y old f of y x old y old, and this is true for all the functions. So from here we can say that suppose if x new comma y new is solution, then this will give me f of x old comma y old plus x new minus x old f of x old comma y old plus y new minus y old f of y x old comma y old is equal to 0. So this is my principal equation which will be used to find the roots. So if I write down that equation, then it will become, suppose there are I equations or functions. So for each I f of I x old y old plus x new minus x old f I x x old y old plus y new minus y old f of I y x old comma y old is equal to 0, and this will give me a matrix which will have this f of ix x old comma y old, f of iy x old comma y old, x new minus x old, y new minus y old is equal to f of I x old comma y old. So this what I call f ij multiply delta xj is equal to f of I. So this is what I call. So what we have is f of ij delta xj is equal to f of I. This implies delta xj will become f of ij inverse f of I, and this is being evaluated at old values. So this implies my xj new will become xj old minus remember that there will be a plus sign and it will be equal to 0. Xj new will be equal to xj old minus Fij inverse evaluated at old value and Fi evaluated at old value. So this is a generalized form. I will explain each term. So this is the new value of xj which is at the next iteration, and this is the old value of xj at the previous iteration, and this is Fij inverse using old values, and this is Fi using old value. So this is derivative of function I with respect to the variable j, and this is value of ith function. And we will keep updating this thing or iterate till my xj new minus xj old is less than epsilon 1 and my fi less than epsilon 2. So this is my convergence criteria. Epsilon 1 and epsilon 2 I can decide based on my convenience. So I'll give you one example of this, that how this is written in 2D. In the next video I'll give you that example. Thank you.